Welcome to another exercise in the workbook Statistics. This time I'm going to focus on an exercise about the hypergeometric distribution. Let's have a look at the exercise. Here we have, to prepare for an exam, a student selects 7 out of 150 exercises from a workbook. 10 of the exercises in the workbook are on the hypergeometric distribution. The first task we then have to solve is what is the probability that none of the selected exercises will be on the hypergeometric distribution. Second, what is the probability that at most 2 exercises on the hypergeometric distribution will be among the selected ones, so among the 7 one. Finally, what is the probability that 2 to 3 exercises from the selected 7 will be on the hypergeometric distribution. Well, before we can start with any of the 3 parts, let's first clear why are we actually going to use the hypergeometric distribution in this case. Well, we can assume that the student selects the exercises randomly, and well, if he really tries to learn, he will select 7 different exercises. He will not select 7 times exactly the same exercise. So if he selects them randomly, this means there is no replacement. Each exercise can be selected only once. Well, no replacement, that's an indicator that we are going to use the hypergeometric distribution. Well, with this cleared, we can actually jump right into it and start with the first part. Here, what we are looking for is the probability that our random variable is 0. None of the 7 exercises should be on the hypergeometric distribution. None means exactly 0. Well, what do we know? We know that in total there are 150 exercises in the workbook. 10 have the property of being on the hypergeometric distribution, and we draw a sample of 7 exercises. Well, with this in mind, we have all the 4 numbers we need for the probability function of the hypergeometric distribution. So we can simply insert this. We have 10 over 0, so that's large K over small k, times 140 over 7, so that's large N minus large K over small n minus small k. All of this is then divided by large N over small n. So that's more or less representing in our sample the exercises which should be on a hypergeometric distribution. That's representing the exercises in our sample which should not be on the hypergeometric distribution, should not have the characteristic we're talking about here. Well, if we input this in a calculator, we get as a result 61.06%. So the chance that none of the exercises will be on hypergeometric distribution are roughly 61%. Well, that already finishes this first exercise, or first part of the exercise. So let's carry on with the second one. In the second one, what we are looking for is that 2 or less of those exercises are on the hypergeometric distribution. Here we could do 2 ways. We could either work with what's written here, smaller or equal to, or we could use the counter probability. So 1 minus everything larger than 2. Well, if we talk about larger than 2, we have 3, 4, 5, 6, and 7. So we would have to calculate 5 probabilities. Here, smaller or equal to 2, we have actually only 3 probabilities. For 0, for 1, and for 2. Well, not only 3, this one we did in the exercise part A, so we actually only have to calculate 2 new probabilities. So that's much less than if we were to use the counter probability. So we're going with this way, and as I said, we're going to take for that part the result we have from the exercise part A. Again, we have the same information as before, K, large K being 10, large N being 150, and the sample size being 7. So we could just insert for this part the result from part A, and here respectively the numbers. As we see, the only things which change are the numbers down here. That's small k, that's a 1 and a 2 here. That's small n, the 7 minus the 1, the 7 minus the 2. Again, inserting this into our calculator yields as a result 99.34%. So more than 99% chance that less or 2 or less exercises will be on the hypergeometric distribution. Well, that was already the second part, so only one part to go. And in this third and final part, what we're looking for is between 2 and 3. Well, that's actually a very complicated way of saying it should be 2 or 3. Because here we have a discrete distribution. Discrete means we can only have integers as values. Well, there is no integer between 2 and 3, so 2 and 3 are the only values we get. Again, we have the same values given as before for large k, large n, and small n. So we're simply going to insert what we have here. Well, we do not actually have to calculate this much because this part we can simply copy paste from exercise part B, where we already calculated that one. So only the part for 3 would be new. So here we have the small k, small n minus small k, and as a final result we will get 7.01%. So slightly more than 7% that 2 or 3 exercises are on the hypergeometric distribution. Well, this then concludes this exercise. I hope you enjoyed it, and I say goodbye and see you next time.